Welcome to Industrial Engineering Jargon Talks, where we make learning industrial engineering jargons easy and fun. Let's dive in together and explore the exciting world of I. Are you ready?
Brief article number 1, Applying Statistical Process Control in Industrial Engineering.
In the field of industrial engineering, Statistical Process Control, SPC, plays a crucial role in ensuring quality control and optimization of manufacturing processes. SPC is a method of monitoring, controlling and improving a process through statistical analysis of data. It involves the use of statistical tools and techniques to identify any variations in a process, and then take corrective action to maintain the desired level of quality. SPC is widely used in industries such as automotive, aerospace, and pharmaceuticals, among others. One of the key benefits of SPC is that it helps organizations to reduce waste and rework by identifying and eliminating the root cause of any defects in a process. SPC relies on the use of control charts, which are graphical representations of process data over time. By analyzing the data on a control chart, an engineer can determine if a process is stable or unstable, and identify any special or common causes of variation. The most commonly used control chart is the X-bar chart, which plots the average of a sample of data over time. Another important tool used in SPC is the Pareto chart, which helps to identify the most common sources of defects in a process. It is a bar graph that shows the frequency of defects or errors in descending order of importance. The chart can be used to determine which factors are contributing the most to a problem, and prioritize corrective actions accordingly. Pareto charts are often used in conjunction with cause and effect diagrams, also known as fishbone diagrams, which help to identify the root causes of defects. SPC requires a solid understanding of statistical concepts such as mean, standard deviation, and normal distribution. Additionally, engineers need to be familiar with process capability indices such as CP, CPK, and PPK, which are used to evaluate the ability of a process to produce within specification limits. These indices are calculated using statistical software and provide a numerical measure of a process's ability to meet customer requirements. SPC is also an important part of Six Sigma, a data-driven methodology for process improvement that aims to minimize defects and variability. Six Sigma emphasizes the use of SPC as a tool for continuous improvement, and includes additional tools such as design of experiments, DO, and failure mode and effects analysis, FMEA. These tools help engineers to identify the factors that contribute to process variation, and develop effective solutions to improve the process. In conclusion, SPC is a critical tool in the field of industrial engineering that enables organizations to achieve consistent quality and optimize their manufacturing processes. By utilizing statistical techniques and tools such as control charts, Pareto charts, and process capability indices, engineers can identify and correct any sources of variation or defects in a process. SPC is a key component of Six Sigma methodology and is used in a variety of industries to achieve process improvement and customer satisfaction.
Okay, now it's time to review and practice the jargons and important words of this short article.
First jargon: Statistical Process Control, or SPC. Definition: a method of monitoring, controlling, and improving a process through statistical analysis of data. Important word: quality control. Definition: the process of ensuring that a product or service meets the desired level of quality. Important word: optimization. Definition: the process of improving a process to make it as efficient and effective as possible. Special concept: variations. Definition: differences or deviations from a desired or expected outcome. Important word: control charts. Definition: graphical representations of process data over time that help to identify any special or common causes of variation. Important word: defects. Definition: flaws or errors in a product or process that do not meet the desired level of quality. Important word: waste. Definition: any resources or materials that are used inefficiently or unnecessarily. Important word: rework. Definition: the process of redoing work that did not meet the desired level of quality. Jargon: X-bar chart. Definition: A type of control chart that plots the average of a sample of data over time. Jargon. Pareto chart. Definition. A bar graph that shows the frequency of defects or errors in descending order of importance. Important word. Factors. Definition. Variables that contribute to a problem or issue. Important word. Prioritize. Definition. To arrange or do something in order of importance or urgency. Important word. Corrective actions. Definition. Steps taken to eliminate or reduce the root cause of a problem or issue. Jargon. Cause and effect diagrams. Fishbone diagrams. Definition. Tools used to identify the root causes of defects. Special concept. Mean. Definition. The average value of a set of data. Special concept. Standard deviation. Definition. A measure of how spread out a set of data is from the mean. Special concept. Normal distribution. Definition. A probability distribution where the data is symmetrically distributed around the mean. Jargon. Process capability indices. CP, CP key. Definition. Measures of a process's ability to produce within specification limits. Important word. Numerical measure. Definition. A quantitative value that represents a characteristic or property of a process. Jargon. Six Sigma. Definition. A data-driven methodology for process improvement that aims to minimize defects and variability. Special concept. Continuous improvement. Definition. The ongoing effort to improve a process or product over time. Jargon. Design of experiments. DOE. Definition. A method of testing and evaluating different variables to optimize a process or product. Jargon. Failure mode and effects analysis. FMEA. Definition. A tool used to identify and prevent potential failures in a process or product. Special concept. Process variation. Definition. Differences or deviations from a desired or expected outcome in a process or product. Important word. Consistent quality. Definition. The ability to produce a product or service that meets the desired level of quality on a consistent basis. Important word. Optimize. Definition. To improve a process or product to make it as efficient and effective as possible. Special concept. Industrial engineering. Definition. The branch of engineering that focuses on the design, optimization, and management of manufacturing processes. Important word. Customer satisfaction. Definition. The measure of how well a product or service meets the needs and expectations of the customer. Special concept. Process improvement. Definition. The ongoing effort to improve a process or product over time.
Thank you so much for watching this video. Don't forget to subscribe and make sure to press the bell icon to get notifications when we upload a new video.